just in case. Okay. All right, I think I have everything on. Hopefully, we're actually getting some sound. Welcome to Complex Analysis, day number 1 of class. I don't think that anyone was watching this live, which is fine because there's probably going to be technical issues. I'm hoping not. But if there were, I wouldn't want anyone to waste their time with this first class. So I figured I'd just stream it to an empty audience, make sure that it actually works out, check out the recording, make sure it's all good, send it out to you guys, and then we'll go live for Friday's class, make sure everything is set up for that. So today we really probably won't actually touch on any of the course material, just going over some syllabus stuff, kind of explaining how the class is set up, what to expect, what you'll see going on when you jump in the WIO courses page. So let's start right there. I'm going to throw this in student view in WIO courses so you can sort of see what it looks like. This is just what you'll find when you get in WIO courses. You go to the complex analysis page. If you haven't, well, actually, I'm sure everyone here has gone to WIO courses before, but if you haven't, you go to the dashboard and then you jump into the course. And since I'm in student mode, that just got messed up, whatever. But anyways, you'll land here. It's pretty simple. I've tried to make this course as straightforward as humanly possible. The main idea is that you're not going to have to do anything except watch lectures. You can watch them either whenever you want, since this is a fully async class, or if you feel like it, you can watch them live when I record them. On one hand, this saves me a little bit of time having to do a lot of editing and trying to make all the lectures super tight, making sure we hit everything in just exactly the right way, because now you can come in and you can ask questions live if you want. So if you feel like you're not following along, instead of me having to do just like the truly most perfectly tight lecture videos every single time, you can instead just jump in the next class and actually ask me questions if you feel like it. Or if you want to go straight for async, you can email me questions anytime. We'll talk about that stuff more. But the motivation here is basically to give you a live option if you want one, or if you'd prefer to do it on your own time, let you do that. So when you land on the main page, you'll see the 2 buttons you need for this. There's a link to the Twitch page. Let's go to that. We'll probably end up with a weird, like infinite mirror kind of thing, because we'll see that I am currently streaming right now, and that'll kind of just probably go into infinity. Yep, you can see it happening right now. But there is the page. If I'm not streaming, you would see different things. So I'm going to go out of that. Though it is kind of fun to watch. But all right, and then the previous lectures, well, you'll be able to also watch them on the Twitch. It'll record them, but you can also go to the YouTube channel. I have a calculus series up there, and now I'll put a complex series up there too. So that'll make it easy to watch lectures when you want, or go live if you want to actually participate and have some fun with me while I record the lectures. So other stuff in the WIO course page here, you can jump in the files section since we're just going down the list here. The file section is where you'll get all the files, all the things like that you'll need for the class. So files you'll need for the class, there's not a ton. The first folder, course image, I wish I could just hide this so you guys wouldn't see it there, but I think it messes things up if I do. That just got like the logo and stuff. You don't need to ever care about that. In fact, maybe, no, I can't hide it. And then there's a homework assignments folder and a syllabus folder. So in the syllabus folder, you can find, as you might imagine, the syllabus. And then in the homework assignment folder, you will find the homework assignments and the answer keys as I make them available. No assignments on the first day. Don't worry about that. Speaking of going on to assignments, there's nothing else in files. It's super simple. Just assignments and keys, really all you should ever have to do in there. And realistically, you actually don't have to even go in the files section unless you want to. You can always just go to the assignment section and then click on the assignment. When the assignment opens up, you'll get a link to the PDF of the assignment right here. This one doesn't have one up yet because it's the first day of class. But when you do it, you'll be able to just access the PDF. You do your assignment, write it on paper, type it up, however you feel like doing it. And then you submit the assignment. So let's see. Yeah, you just go click that start assignment button, and then you can upload the file if you want. You could, please don't use your webcam to take a picture, but I guess you could if you felt like it. You can scan your homework assignment. You can take a picture of it, but hopefully like a good high quality picture, something that I can actually read. So if you take a good high quality picture, I mean everyone's phone is high quality enough nowadays that I should be able to read it. Take a good high quality picture of each page of your homework assignment, upload it here. You're good to go. It's not a big deal. And then you click submit assignment. I'll be able to add annotations directly to the assignment, grade it like that. But that brings us to our next item, grades. Or actually, I guess before we jump into grades, I should be clear here. The assignments tab has all the assignments, but it also does have the exams on there just in case you're ever looking for the exam due dates. You can see that they're right there, and you can also see the point breakdown and everything. But just to mention it, you can look by date or by type, so you can see all the assignments and then the 3 exams. We'll talk about that in a little bit. But next tab is grades. So if you go to grades, you'll be able to see your homework assignments and exams, your scores, and then what they're out of. Super easy, very simple. There's a Zoom tab. We'll touch on that in a little bit. There's a People tab. I won't click on that right now since we're streaming it, and I want to make sure that everybody's privacy is protected. I won't reveal anyone's identities and break regulations with that kind of stuff. But if you're in the class, it's useful in case you want to reach out to a classmate through their university, the WIO courses system, and arrange study groups or ask questions. You can always email me too for those kind of things if you don't want to do that. But now here we are onto the real meat of it. We've kind of explored most of what's in the WIO courses page. There's a few items down here that are just additional syllabus stuff. Look through them. But the syllabus right here, if we click on it, here's what, the usual thing we go over on the first day. If we were in person, I would be passing this out to you and talking you through what to expect. So syllabus is pretty self-explanatory. I, of course, like all professors, encourage you to actually read through it. It's always a good thing to do. But basically, it lays out the class in hopefully an easy to understand manner. All we're doing here is just going through a really excellent text, Marsden and Hoffman's Complex Analysis. It's a great first introduction. I know a lot of people have very strong opinions about which complex analysis textbook you should use. I think this one has been used here in the past, and it's a good one. It's a good one. It's laid out kind of like a regular calculus book, maybe less like Stewart's or one of those ones, but it's pretty well structured, and I think it will feel familiar if you've taken some of the calculus sequence, which I believe everyone here has. So it talks a little bit about what we'll go over. This is really kind of just almost pulling from the table of contents in the text, so don't need to worry about that too much. But you can read through it if you want to get a peek of what we're going to talk about. But beyond that, let's get into the stuff that everyone cares about in the syllabus, which is the grading scheme and how this class will actually go down in terms of the grades you'll get and the credits you'll receive. So pretty easy. Bunch of homework assignments, 3 exams. Okay, straightforward. Since everything's asynchronous, all of the exams and all of the homework assignments will obviously be digital and given outside of class time. So exams have a start date and an end date, a due date, and homework assignments become available at a certain point. You can consider that kind of the start date, and then there's a due date where you turn it in. Now, I totally get that in a upper level math class like this, it can be kind of brutal to do all of the problems directly and have them graded directly. So if you want to skip this uh, kind of component here, I've tried to set up the class so that you don't have to worry about being right more than you have to worry about learning the material. Hopefully those two things always go hand in hand. Hopefully every time you do a problem you get it right and you understand the material. And I really think also that it is hard to understand the material if you don't get it right. However, I don't want and this is I'm trying to kind of dance around this. I don't want you guys to cheat, right? This is an online class, and kind of one of the big things that people tend to do in online classes is just, kind of ignore the lectures, do the homework, and cheat. And so hopefully we will be able to get around this to the greatest extent possible by allowing you to not really have a particularly good reason to cheat. Um, I mean, at the end of the day, it's really difficult to stop cheating entirely. I'm not remotely encouraging you to do it. It's a waste of your time and money um, to cheat. But hopefully, I'll remove the impetus to make people who don't want to cheat but otherwise might to try to preserve their GPA do so. Basically, the idea is that on all of the homeworks, you'll have to submit it by, instead of the due date, let's call it the check date. You'll have to submit it by 11:59 p.m. on the check date. So you can submit a typed, handwritten, whatever, scanned, take a picture of it, copy of your assignment to the WIO courses page like we went through. Then I'll go through and I'll verify that you've made, what I would reasonably consider to be a good faith effort to complete the assignment. Hopefully this means that you just did all the problems. If there's one of them that you really can't get, kind of try to do it, go as far as you can. But if you're like, I don't know how to do this part, please take me up to the point where it breaks down. I'll explain exactly how to go from there. I'll try to go through everything necessary, but do as much of it as humanly possible. And give it to me. I will not, if you make small mistakes, please always try to correct those. Read through the feedback I give you. I will try to be relatively involved at first, at least, with the feedback, and then I might move a little bit more towards as needed or as you want feedback form. But the idea is that instead of worrying about, like, oh, I didn't do great on the first exam, I better just, cheat on the homeworks to try to, keep my GPA up. The idea is that as long as you actually participate with the homework, it serves its purpose. As long as you're learning from it, it serves its purpose. I don't want to ding you for sign errors when the sign errors don't really, have give any good sense of whether or not you understand the material at hand. I want to be grading whether or not you understand complex analysis. And that is the biggest and most important part of your grade, and always will be. I'll make you that promise. I will grade you solely on whether or not you understand the material as much as I possibly can. Of course, there are some due dates that we can't entirely avoid. There will be times where, the class will end at some point. I have to put a grade in, so there is due dates ultimately. But my main goal is to make sure that you understand the material and have your grade reflect that as accurately as possible. Since the homeworks are, graded on in terms of whether or not you've made a good effort to do the assignment, there is a little bit of give and take here in terms of due dates. Namely, after you complete the assignment, I'm going to post a very detailed and nice answer key to the assignment. The solution key becomes available once the assignment's done, and since it is impossible to gauge whether or not you did the assignment before, or with or without the help of the solution key, after it's posted, I will require your attempt to be submitted before the solution key becomes available. So for that reason, there will be due dates associated to the homework assignments. It doesn't mean that everything has to be perfect. If you're really struggling with a problem, don't stay up all night, just go to bed. Try it out the next day or something. Use the solution key to figure it out. But do submit your assignments by the due date. I'm just checking that you're actually keeping up with things. This class will move relatively fast, and it is very easy to fall behind, especially if you start to struggle with some of the material. So you don't have to get everything right. There's no good reason to cheat. I am not asking that you be perfect on all the assignments, but just do them. Just keep up, and you will get a great grade on your homework. As long as you give good, solid effort. Of course, if you're turning them in with 0 problems done and saying, hey, oh, it was the best I could do there. It's, there's some like level of effort that I expect. But if you're making a good faith effort to trying reasonably hard to get them done, you don't have anything to worry about. The homework is not supposed to be the stressful part of this class. That part is the exams. So the exams, hopefully it's not the exams, but there will be 3 exams. Each of them accounts for 20% of your grade, so for a sum total of 60%. You can't just cruise off the homework to an easy pass. You have to actually do all right on the exams. And the exam section by section breakdown right here in the syllabus. So we'll do Chapter 1 and 2 on Exam 1, Chapter 3 and 4 on Exam 2, Chapter 5 and the very beginning of Chapter 6 on Exam 3. So before anyone asks me 100 times at the end of the semester, the final is not cumulative. It is just on those sections listed right there. And then the written homework is the other 40% of the grade beyond the 60% accounted for by the 3 exams at 20% each. Grading scale, very easy. 90 to 100% is an A, 80 to 90 is a B, so on and so forth. I don't really like to do plus minus grades unless there's some particularly good reason for it. I don't even think the university likes us to do that either. Extra credit. I am always open to extra credit. If you think that your grade at some point does not reflect your understanding of the material, I invite you to prove it to me, and I will give you ample opportunity to do so if you're willing to do the work. However, outside of circumstances like that where you come to me looking for it and being willing to actually do a substantial amount of work to demonstrate your understanding of the subject matter, don't expect extra credit to do too much. It might make up for, missing an assignment or something like that. Maybe, biffing a question on an exam, but it's not going to be a substantial portion of your grade as it's set up. However, like I said, if you get to the end of it and you're like, wait, I'm going to not pass this class, but I actually get this. I'm one of those weird guys. I'm totally fine with dramatically changing a grade if you can show me that you understand the subject matter. In my view, and maybe I'm somewhat unorthodox with this, in my view, your grade in this class should reflect your understanding of the material taught in this class. So if you didn't do a single thing the entire class, I didn't even see you once, and you show up on the last day before grades are due and you say, Bryce, well, maybe not the last day because it might take longer to assess, but at the very end of class, and you go, Bryce, I can show you that I have this mastered. I am an absolute god of complex analysis. I will be like, all right, prove it to me. And if you can prove it, I will give you a passing grade. Don't try that, please. I would be amazed if you did it, but I really think that the number of supernatural geniuses who can, master a subject in like a single evening is very small. And if you already know the subject, then you probably aren't taking this class. So try to stay up to date with things, but just don't give up, basically is what I'm saying. If you get to a place in the class where you feel like it's hopeless, what I'm trying to say is that it's not. If you will put in the work to understand the material, I will try to help you as much as I can to get you to a place where I can confidently give you a passing grade because you have a passing grade worth of understanding. So there is never some point where you should just quit. You can always bounce back as long as you're willing to put in the work and genuinely learn the material. That being said, try not to fall behind. It's always easier to stay up to date with things instead of catching up. So yeah, that's my spiel on that part, and it was kind of a long spiel. But anyways, next little bits of the syllabus. Attendance. So this class is asynchronous. Attendance is, in that sense, kind of synonymous with watching lectures or reaching out to me if you need help. I can usually answer questions via email very quickly. We can schedule one-on-one Zoom meetings to work through questions together. And, really I can work with you in whatever way you need. So if you want, to email me questions as you have them, I can send you back nice answers about things. If you want to, if you find yourself struggling and you want to set up weekly Zoom meetings for a little bit to do some one-on-one tutoring, we can do that. If you just need a one-off Zoom meeting or an occasional email, that's totally fine. Whatever works best, just reach out to me. Do try to keep up with the lectures. If you start to find yourself struggling, try maybe going to the live stream lectures instead of just watching them afterwards. That way you can ask questions as things happen. If that doesn't work with your schedule, no worries. Just ask me questions after you watch the lecture. Easy. But if you do this, I think it shouldn't be too bad to pass this class, or at least do very well in it, or at least do reasonably well in it. However, if you don't do these things, I will not have that much sympathy. I will always give you a chance to prove that you know the material, but the extent that I'm willing to work with you in an exceptional circumstance is very much proportional to how reasonable it is, how exceptional the circumstance actually is. If you just don't watch the lectures, you don't reach out to me, and you find yourself partway through the class and hopelessly lost, I don't know if I'm going to work an extra 20 hours a week to try to catch you up. I will work with you, but we have other students here too, and I will try to make it relatively fair. So if you fall way behind and other people need help, you may not be able to get quite as much as you want. All I'm trying to say is, once again, just keep up with things. It's a lot easier to do this in person than it is with an asynchronous class, so just be mindful of that. It's a lot easier to feel like you haven't fallen behind when you know that there are just videos that you can watch whenever you want, but while maybe watching a few hours of lecture videos doesn't seem like that big of a deal, you could just do it all on Saturday or something like that. There is something to be said for giving yourself time to digest the material. It is a lot harder to watch 3 straight hours of lectures and really get it than it is to watch an hour of lecture, wait a day, watch another hour, wait a day, watch another hour, and then have a whole weekend. You have a lot more time to kind of mull it over, ask questions as they come up, and really think through it. So just, keep up and let me know if you need any help. In terms of getting help, since this is a little bit more of the upper division in terms of the undergraduate course catalog here, some of the nice standard features at UYO are not as readily available. So things like the CHASM, they don't, I believe, tutor for complex. However, you can probably find a grad student in there who can help you out. But I won't officially advertise that you should go to the CHASM, since I don't think it's technically in their offerings. However, making study groups with other members of the class is a great idea. Hitting me up for help, either via email or to schedule a Zoom meeting, which we can do whenever works for you. That is another great way. Taking the office hours. Oh, we have someone is watching. What's up? All right. They only stop at math seminar. Oh, they. Okay. Yeah. Yep. So in the chat, we've got confirmation, I believe, that we don't do complex in the CHASM. That is good to know. Sweet. But yeah. Anyways, cool. Glad that someone's watching. That's awesome. I didn't even. How did you know? Did it? Oh, you must have subbed and then got like a notification. Yeah. Cool. All right. Makes sense. Nice. Okay. So yeah. Sweet. Yeah. The rest of this is just the usual stuff. So, academic dishonesty, don't cheat, disability statement, If you need assistance, contact the university's disability support services, and then there's a changes to the syllabus piece. It's all about, if we change stuff, I'll let you know. It's pretty simple. There's a grading rubric in here explaining what I hope to see in written work. If you're at this point in your math career, you probably are relatively familiar with what people expect. So you can go through this if you like, but we won't spend too much time on it here. The big thing that's probably useful is the course schedule. So here it'll be a day by day of what we'll go through in class, which sections we'll cover, and I've tried to lay it out as forgivingly as possible. I've given ourselves 2 days for each section, and it just pretty much goes like that. 1, 1, 1, 1, so on and so on. With homeworks due on Friday by 11:59 p.m. so you can enjoy the weekend. With a few exceptions. For example, on February 18th, we have semester break, so there's an extra day off right there. Instead of having it due on your day off, I just pushed it to the next Monday. Give you a little bit extra time there. Then there's a few when we come up to exams where homeworks will be due on the start date of the exam. So for exam 1, you see start date right here on March 9th, due date on the 11th. So that means that at the stroke of midnight on March 9th, when it turns into March 9th, you will be able to access the exam. And then by 11:59 p.m. on March 11th, you will have to turn in exam 1. So you have a fair amount of time right there. And then homework 7 will be due on the same day the exam becomes available, just to give you a little bit more time right there. So we just do lectures right up until exams, have a little bit of extra time. This first exam is kind of weird right here, since it's the spring break week right afterwards. The Friday before spring break tends to get virtually no attendance. I wish that wasn't the case, but it is, and then you end up basically losing whatever you did. So we might do something there, but realistically, since it lines up really well with the exam, we might just take that Friday off. Whether we do a review day before exam 1, maybe on the 9th or something, is kind of up to you guys. We'll figure it out once we get there. With spring break, it's always kind of hard to coordinate. Anyway, going on down, just once again, homework assignments on the Fridays, 2 days for each section, easy enough. Exam 2 will go from April 22nd until the 25th, and then we'll do a few more sections and we'll end with the finals. So the finals over. I've tried to set this up. If you kind of zoom out a little bit here, you can see that we have, pretty much this whole first chunk to exam 1, then a little bit smaller chunk to exam 2, and then a much smaller chunk on the final. So the idea is that the class gets harder over time, so we do less material per exam. And hopefully that keeps a relatively consistent level of difficulty without making it too ridiculously brutal by the end of class. Seem good? Cool. All right, so there is the syllabus tab. You can check out the syllabus. There's also a course summary in terms of all the due dates right here. And then the rest of it just has some learning tools, stuff about DSS, campus resources, STEP, tutoring center, all that sort of stuff. Big long thing here about, these are just additional syllabus tabs. I encourage you to check them out. We won't walk through them. I'm sure that these are in every class you take. But there is Intro to Complex. Cool. I'm going to leave student view right now. Nice. And yeah, let's talk a little bit about the textbook. That's probably the thing that people care about most after the grading scheme. If you have already bought a textbook, cool. I hope you didn't pay a huge amount of money for it. The book is Marsden's Complex Analysis, Basic Complex by Marsden and Hoffman. It is a classic, relatively old book by this point, but luckily mathematics doesn't tend to change much. Well, the way we write it might change, but this is recent enough that there are no real big changes, and you can get it for reasonable prices. If you want to go buy it new, you will probably spend a lot of money. If you go, say, on Amazon and you buy a used hardcover copy, you can get for like $40 or something like that. Paperbacks, I think, might be a little bit more. I don't know. I think it's $70. I don't know. Yeah, it's still a little bit much. You didn't hear it from me, and of course, I would never encourage piracy, even if it's for a good purpose, like learning mathematics. But if you just Google Marsden complex analysis, I have no idea whether this is supposed to be up here, but I think it's like the third search result, at least for me. If you click on it, it is just a WordPress link to, I believe, the entire book online as a PDF. Um, yeah, it's just right there. So if you are fine with the digital copy, that is great news. You don't have to worry too much. You can just do that. Oh, we got my dog barking. All right. Anyways, so yeah, so there you go. It's a good textbook. We'll go through it. As you can see, there are 8 chapters. We'll only be getting through 5 and then part of the 6. This covers. I mean, it's a good 400-ish pages of textbook. If we went all the way up to 8, it would be kind of pretty dang far, and a bunch of the stuff in chapter 8 will be covered in, or should be covered at least, in a ODEs or PDEs class at the undergraduate level as well. So we can kind of skip a few of those things. And then the asymptotic methods, we can skip a bit of that too if you're into, well, we don't need to cover why we'll skip it. There are other classes you can take at the undergraduate level that probably cover some of the stuff here. Like there's a fair bit about steepest descent, and if you're into numerical or computational methods, you'll get that other places. They're useful to read. It's not that many pages. It's only chapter 7 and 8 only cover like, I don't know, 70 something pages. So we're covering the vast majority of the book. There's just a little bit left over at the end. It's not too much. We'll skip those last ones though. We'll just try to get up to the fun and exciting thing for a lot of people is analytic continuation. People like that. It'll let you understand fun topics like the Riemann hypothesis. Everybody likes to hear about the Riemann hypothesis. It's one of the most famous questions in mathematics, whether it's true or not. And we'll get to the point where we can talk about that in a meaningful way and hopefully explain what is really going on there. We won't talk about like the prime number theorem or any of that stuff. That can be saved for, well, actually they probably wouldn't. I don't know if they'd cover that in a number theory class here. Maybe, but we'll at least explain how we can, what the heck is going on when we talk about analytic continuation, and we'll even get to some of the fun stuff with like some of all the positive whole numbers is -1/12. Ooh, like you've seen those things maybe. We'll talk about what people mean with that. Anyways, enough of that for now. That's a long ways away. We're going to start out just talking a little bit about analytic functions. We'll get into Cauchy's theorems, and then we'll start talking about series representations, talk about residues. Then we'll get into conformal mappings and some of the transformations that you might care about in complex analysis. Then we'll briefly touch on analytic continuation. We'll pretty much be done there. So that is the book. You can find it online. It is very easy to find. If you want a physical copy, it's relatively cheap. I heard from a student that the bookstore has not yet gotten it in. I don't know if that's still true. If it is, that's unfortunate. I did send them the ISBNs, but these things do happen. Either way, you can get it off Amazon for really cheap, or you can just find a PDF to use for now, or you can just watch lectures and you'll be okay. So that's that, I think. If we want to jump into, let's see if this works. Jump into a little bit today, since I guess we have some folks around. I won't keep everyone too long. Everyone likes to get out a little bit early on the first day of class, but let me put on my weird half-hand glove thing to use with the old drawing tablet. And we can jump in and see if this works all right. Okay. Let's check this out. All right. Here, let me crop this a little tiny bit. Ah, hell. I'll figure that out later when people aren't sitting around the chat, whatever. Anyways, let's see if this works all right. I have this set up, so hopefully it does. Oh, okay. Let's see, I knew this would happen. All right, sorry guys, 1 second. Let's see, I gotta modify the, I had to write a little shell script to make this tablet work. Am I not on DVI 0? Let me try HDMI 0. Okay. Sorry about this. Oh. What the heck, yeah. Alright, yeah, and then... Yeah. Nope. Alright, just 1 second, guys. I knew this would happen. Alright. Always a beast trying to make this go. Alright, let's see. Oh, I'm gonna accidentally make that go crazy while I switch which screen I'm capturing. Oh. There we go. Alright, let's see if this works now. Gosh, I hope so. Let's see. Sorry for the hassle. Alright. Yeah, that's gonna... I think that'll be fine. Okay. Cool. Okay. So that does work, and we have the drawing tablet up and running. Anyways, this shouldn't be too difficult to use, I hope. We should be able to do notes pretty well. I can just always grab. Well, I have prepared canvases to do all the things on, but let's just talk a little bit right now, just to start things off with a very basic idea of what's going on in complex analysis. So thanks for bearing with me right there with the technical difficulties. Hopefully this doesn't happen too much in the future. Also, hopefully the audio is okay. I got a new mic, so I think it should work a little bit better than what I had before. Anyways, actually, let me move that slightly. Anyways, so the basic idea of what's going on in complex analysis is that the historical perspective, at least, is that when you're dealing with regular old real numbers, certain equations, things like x squared plus 1 equals 0, things like this don't have solutions. This guy has there's no real solution. So no real number satisfies this. And that's an issue. At first, this, I mean, of course, I'm going to try to avoid the, complex numbers aren't imaginary, they have a real blah, blah, blah. I'm going to try to avoid that, but I'm just going to try to motivate this in the obvious way, which is that this having no real solutions is no stranger than the fact that, say, 2x minus 1 equals 0 has no solutions that, or actually, yeah, here, has no solutions that are, well, let's just go through it for a second. This has no solutions that are whole numbers. Namely, the solution is, x is 1/2. So this guy, this is a rational number. This is a rational solution. This guy here has no integer solutions. So the fact that this guy has no integer solutions doesn't seem weird. We don't look at rational numbers and go like, that's not real. Like, how can you have a half? Like, you can only have whole things or something. So it's really not crazy to basically consider our number systems as being built out of other ones. So if we started, and this is where we can kind of get a good intuition for the construction we'll be doing here. Oh, the audio is a bit quiet over there. Okay, let's see if I can boost that up a little bit. Maybe I just have to get closer to my mic. Is that any better? Hopefully. Okay. Let me know if it is. So the idea here is that we might start out with, say, let's call it n for the natural numbers, and whether or not this is how you want to do it. Some people like to include 0, some people don't. We'll include 0 here. Let's just say 0, 1, 2, 3, so on and so forth. I'll do some dots right there, and I'll put this all in set brackets. Some people hate when you write like this, but whatever. The natural numbers, the positive whole counting numbers, these guys, or at least non-negative whole counting numbers, these guys, it's a good number system. It's what you can count on your hands and stuff, right? These guys are good. Now, if you start to consider equations like, say, let's jump to a different color here, keep this clean. Let's say x plus 1 equals 0. This guy has no natural solutions. There's no solution in n. Oh no. That seems like an issue. So what could we do? Well, we could add some extra stuff. We could, and I'm not going to do this in the classic way where we do all the formalism of adjoining new things, but really that's what it will amount to if you're familiar with it. And so we can get on to z. Maybe we got like, I'm going to have to do this like weird with a double dots, basically. And and so on. Here we've got z, the integers. This is all of the positive and negative whole numbers. And this is good. Now we have solutions to things like this. The solutions live in here. Okay, cool. So we run into yet more problems, however. Once we encounter things like, I don't know, I think we just did one a second ago, 2x minus 1 equals 0. I should have put hats on my ones. 2x minus 1 equals 0. This guy has no solutions. Oh, wait, should I say 2x minus 1? Yeah. In z, in the integers. There's no solutions. Oh no, so we have to add more stuff, and we get to the rational numbers. This guy will have solutions in the rationals. So what are the rationals? Well, they're a little bit harder to write like this. So I'll just abuse notation a little bit. I'll say Q equals the set of A over B, and I'll say such that, let's just say A comma B, both of those guys are in the integers. So if you're not familiar with this notation, this is called set builder notation, and maybe I'm being a little bit fast and loose here, but it's just all of the things A over B, where A and B are integers. Yeah, fair enough. Okay, so these are just all the fractions. And once we get to fractions away from whole numbers, then we have something nice. We get back to this guy having solutions. So the solutions live down there. Okay, so we have solutions to that kind of stuff. Oh, but wait, there are things that aren't rational. Oh no, oh no. And this, everyone has probably heard of Pythagoras. This is a fun fact. Pythagoras was a insane religious fanatic, if you didn't know. Pythagoras was just kind of an absolutely crazy person in certain ways. Pythagoras, they worshipped the Pythagoreans, his small cult. They were kind of weird. You had to listen to Pythagoras lecture from behind a curtain for like some period of months or years before you could be admitted into the cult. And the Pythagoreans, they worshipped certain numerical or mathematical quantities, particularly the so-called tetracties of Decad, a triangular number. They I don't know, they believed that certain numbers were very sacred to them, and is basically some, I don't know, Greek type of numerology way back in the day. Anyways, Pythagoras definitely believed that the rationals were all of the numbers, and when eventually it was shown that there were certain numbers that are not rational, supposedly Pythagoras straight up killed a dude. Supposedly they were on a ship traveling between some of the isles, and someone proved to him or expressed to him that a certain equation didn't have a rational solution, and he became so enraged that he threw the guy off of the boat. So Pythagoras is a straight up murderer, if you didn't know that. It's kind of crazy. People talk about Pythagoras like he's a boring dude, but he is really weird. So yeah, Pythagoras straight up killed a dude over the idea that Q is not all of the numbers, the rationals aren't all of them, and that's neat. But basically, there are things like, let's say, I don't know, x squared minus 2 equals 0, something like this. Obviously, the solutions to this are x is plus or minus root 2. Root 2 is not a rational number. Fun fact, if you did not know that, there's a reason we write square root of 2 instead of 7 over 12 or, some other fraction. It's because there is no rational number equal to square root of 2. And once we add in all of these guys, and it is a little bit more interesting, we get the real numbers. And I will avoid doing an equal sign right here, because to write down the set of all the reals built from the previous things becomes a relatively involved process. I won't take you through a formal construction of the reals, since I value your time more than that. No, it is interesting. You should, if you're interested in set theory, it's a great place to learn about that sort of stuff. You also might encounter it in abstract algebra, but let's get away from it for a moment. Basically, this is just all the good old-fashioned numbers we use. Decimal numbers, potentially with infinitely infinitely many, I'll say decimal places, I guess, i.e. stuff like pi, right? 3.14159, blah, 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 forever, right? It's very long, not repeating decimal. You get what I mean. But these are all the good old-fashioned regular old numbers. We like to visualize this like a number line a lot of the times. You put down 0, and basically the cool thing to think of here is basically that R has all the stuff in there. If you were looking just at, say, like Q, it is, if you look at just, say, like the, we draw tick marks, say, for like the naturals or something, like, like 1, 2, 3, and then we want to go to the, integers, we'd start throwing like negatives in there, right? And you get like this like smattering of points in the reals. Okay. And then you want to throw the rationals in there, and it starts to get a lot messier. There's just like a crap load of them, but there's always a rational number between other rationals, right? You can always find one in between them, but it still isn't all of them, right? There's still more stuff in there. So you can imagine it like it's like a very, very dense line. But there's still some kind of a gap. It's not like this smooth, like, unbroken line. You have to add in the irrational numbers to get there. Okay, cool. And that's R. But wait, we still have a problem. So while the solutions to things like this, solutions live here, there are still things that we don't have solutions to. And this is where it gets fun, and that's what we're going to look at when we talk about complex numbers. And this takes us to a pretty good stopping place that highlights that I need to practice more in using this tablet. Namely, everyone knows that we have certain things like x squared plus 1 equals 0. This guy, this has no solutions in R, in the reals. However, it does in the complex numbers. Complex numbers, C. These guys have solutions to this kind of stuff. And you might ask yourself, like, okay, well, are there things like, polynomial equations like this that I can't solve in C? And the amazing thing is that the chain stops. Finally, it stops. It starts at some place and it kind of stops eventually. You can imagine, maybe you could imagine that it might be the case that, you can just always kind of keep going. You can come up with more and more brutal, crazier, weirder polynomials, and you can not find things, and you have to keep adding more stuff. But amazingly, C ends up having all the roots of every polynomial out there. This is a property called algebraic closure. We will not talk too much about that. We might a little bit later, but for now, just think of the intuition as the same that we've done before. So while I am not trying to go for the whole like, imaginary numbers are actually like it's not crazy. Like if you think it's crazy, or if you think it's not crazy, whatever, man. They're around. You can do stuff with them. What I'm trying to say is that the process that we'll use to build these guys is no stranger than what we're doing when we introduced negatives when you were a kid in grade school, or we started dealing with fractions when you were in grade school, or you eventually learned square roots when you were in grade school. We're just doing the same kind of thing here. We're just going to add a little bit of extra stuff so we can solve some equations. And this will take the form, interestingly, of a number system that is kind of like two copies of the reals, and in fact is very much like two copies of the reals. Namely, instead of having just one number line, you have two, and things over here, we'll call this the imaginary axis, and we'll call this the real axis. And you'll get points out here that are, like, say, like A here and B here. We could represent these as points A, B in regular old ordered pairs, or what we'll do is we'll instead end up writing things like A plus B I. And we'll talk a lot more about what that means, how complex numbers work, the basics of it. In our next lecture, we'll go through that very fast, and then we'll start really cruising next week into some very fun complex analysis. And I think I didn't actually let us out early because of the technical difficulties with the tablet. So I'm sorry about that. But anyways, that's the beginning of it. That's the syllabus. That's the motivation for complex is just, hey man, why can't I solve this polynomial? I feel like I should be able to solve that. And when you move to C, you can. So we'll get into all of the fun things about complex analysis next time, and we'll start cruising. It'll be great. If you have any questions, shoot me an email. Hit me up. I will post this pretty much immediately after we're done here. And thank you to the, I believe, 5 people who joined us live tonight, even though I didn't advertise it. Sweet. Right on. Thanks for taking the class, and I look forward to watching you succeed and a great semester. I'll stick around for a little bit in case anyone has questions, but if you want to go, we're done. Could probably have made this a lot clearer. Anyone still watching? Anyone still here? I think we somehow picked up another person, actually, which is kind of wild. Oh, when will I post the details to the homework? You mean like the actual problems on each assignment? Is that what you're talking about? Oh, okay. Yeah. So I will post the first homework probably on Friday, I think. Then I will post the well. So I always struggle with whether I should post all of the homeworks on like the first day or whether I should leave them and then because normally you end up modifying them a little bit as time goes on. So I'll probably post the first one this Friday. I'll see. We'll see how that goes and how the course progresses for the first few lectures. And if it seems like we're staying on track, then I'll probably post the rest of them. But the first assignment I'll post this Friday, and then we can talk about that in class a little bit. Make sure everyone's on the same page about how to get to it. But no reason to do any homework right now. Just relax and enjoy the start of the semester. Cool. Any other questions? Oh, right on. Yeah, shoot me an email, absolutely, and we can definitely do office hours. Easy, easy. All right. Well, I'm gonna go make some dinner, and I think I'll end the stream here. Thank you all for coming, and have a great night.